Okay, so we're going to start mole conversions today. But before we do mole conversions, we're going to use a technique called dimensional analysis, which you've learned before. I'm just going to use these three problems to remind you of dimensional analysis. First one says, how many minutes in 4.23 hours? So we're going to calculate the minutes in 4.23 hours. You might logically be able to think through this, but I want you to use this method. So in order to convert hours to minutes, we're going to have to use what's called a conversion factor. In this case, we know that 1 hour equals 60 minutes. So this is what's called our conversion factor. We'll then go ahead and set up our 4.23 hours, and then we're going to multiply it by a fraction. The numerator and denominator will be made up by one of these, but we'll actually put 1 hour in the denominator and 60 minutes in the numerator. And the reason for this is we want to be able to cross-cancel our units. So our units have to be across from each other, and they have to cancel. If I had flipped this, where I put minutes over hours over minutes, you'll notice these would not match up, and so it wouldn't work in that case. All right, once I have that set up, I'm going to multiply my numerator divided by denominator, so it would be 4.23 times 60 over 1 hour, or 1, I guess. And 4.23 times 60 gives me 253.8. And then my only remaining units are minutes, so it would be minutes. The last thing you have to remember is sig figs. I start with 3 sig figs here, so I should have 3 sig figs at the end. 253.8 rounded to 3 sig figs would keep the first 3. That 3 rounds up to a 4 because of the 8. So my final answer is 254 minutes. Okay, so what I do in general is I want to determine the conversion factor, and then I'll use the conversion factor, and I'll have to make sure the sides of my conversion factor line up so I can cross-cancel my units. Next one says, how many minutes in 6,543 seconds? Well, the conversion factor is going to be 60 seconds equal 1 minute. So if I start with 6,543 seconds, and I'm going to use this conversion factor, the denominator will be 60 seconds, because that allows me to cross-cancel over 1 minute. So in this case, I'll have 6,543 divided by 60. Remember, you got to multiply the top and then divide by the bottom. So this will equal 6,543 divided by 60 gives me 109.05. My units remaining are minutes. And so I have 4 sig figs. I'm going to keep 1, 2, 3, 4. I got to round up that 0 to 1 because the next number is a 5. So it would be 109.1 minutes. Next one, 40 inches. So I have 40 inches. First, let's do our conversion factor. So how many inches in a foot? 1 foot equals 12 inches. So that's my conversion factor. All right, let's start. 40 inches is what I start with. I'm going to convert that to feet. I know there's 12 inches in 1 foot. Notice I put inches on the bottom so I can cross-cancel. Then I'll have 40 divided by 12 equals 40 divided by 12. This is 3.3. Repeating. Notice this has only 1 sig fig, so it should be 3, and then my units are going to be feet. Okay? So we want to use this idea. Just remember, one, our answer has to have the same number of sig figs as you begin with. And then 2, remember we want to figure out our conversion unit, our conversion factor, and then keep units so we can cross-cancel. The conversion factors we'll be using aren't ones you are super familiar with, like 12 inches in 1 foot, but it'll be 1 mole equals the molar mass, and then 1 mole equals Avogadro's number. Those are the 2 ones. So you always want to keep those in your mind. All right, so let's go ahead and take a look. So it says convert grams to moles. So let's say we have 14.0 grams of a helium to moles. Remember our conversion factors. We have mole to molar mass, or mole to 6.02 times 10 to 23rd. So I'll just go ahead and write that up. let's write that up here. So remember, our mole, 1 mole equals the molar mass. So if you want to convert moles to grams, you would use that, or you could have 1 mole equals Avogadro number, and that's when you want to convert moles to particles. And particles could be like molecules, formula units. Alright, so let's take a look. We're starting with 14.0 grams of helium. We want to convert to moles. So the one we would use is actually this one, because this can get us from grams to moles. So we'll first figure out helium. 1 mole of helium is how many grams? So what's the molar mass of helium? You look at the periodic table. The molar mass of helium is 4.00 grams. Alright, then I start with 14.0 grams, and this is just of helium. And just like we just did, I'm going to use this. So I'm going to put 4.00 grams of helium on the bottom, 1 mole on top. So it'd be 14.0 grams over 4.00. That'll give me 14 divided by 4, using 3.5. Now my units, notice this works so I can cross-cancel moles. Now I should put actually 3.50 because I start with 3 sig figs. So it should be 3.50 moles of helium. Next one, I start with 36.0 grams of carbon dioxide, and I want to figure out the grams to moles. So I want to convert grams to moles. So I'm going to use this conversion factor again, where 1 mole of carbon dioxide is what molar mass? Well, it should be 44.01 grams of carbon dioxide. Then you start with 36.0 grams of CO2. Multiply by the conversion factor. The grams should go in the bottom. And then 1 mole should be in the numerator. This allows me to cross-cancel. So I have 36.0 divided by 44.01. You get that, it equals 0.818 moles of carbon dioxide. I rounded it, it was 81.79, right? But I need to round to 3 sig figs. Why? Because I have 3 sig figs here. Okay, so in this case, if you want to convert from grams to moles, we're going to use the molar mass, okay? What about if we want to do the opposite, though? What about if we want to convert moles back to grams? Well, you'll still use the same conversion. It'll just look a little different. So if I want to convert moles to grams, then I start with 1.5 moles of oxygen. Well, I know 1 mole of oxygen is equal to how many grams? It's 16.00 grams. Okay? And so if I start with 1.5 moles, 1 mole would go on the bottom this time, right? And then 16.00 grams would go on the top. 1.5 times 16 gives me 24. That's the right number of sig figs. These cross cancel, so I end up with 24 grams of oxygen. 3.5 moles of silver. We're going to convert that to grams. Use the same thing. 1 mole of silver equals, and you look at it, it's 107.87 grams of silver. This is according to the periodic table. 3.5 moles of silver times, so we know 1 mole of silver is 107.87 grams of silver. So moles cancel out. 3.5 times 107.87. This equals 380 grams of silver. 2 sig figs. It was 377, but I need 2 sig figs. Right? It was like 377 something. But notice I want to keep this one and this one. This will make it round up. I can replace that with a 0, so it's 380 grams of silver. Okay? So whenever we convert between moles and grams, we use the molar mass. What about if we want to convert between moles and particles? Well, we'll use a different conversion. The conversion we use would be 1 mole equals, now we want to get to particles, so let's use Avogadro's number, because we know 1 mole equals 6.02 times 10 to the 23rd particles. So let's say we want to convert 1.5 moles of calcium to atoms. So we go 1.5 moles of calcium. 1 mole of calcium is how many atoms? Well, it's always going to be Avogadro's number. And when you're counting something, like so, the previous one was about mass. When we want to figure out the mass or the grams, we're going to use the molar mass. Now, if we want to figure out the number of atoms, like it's a counting thing, like we want to know how many number or the amount, we use Avogadro's number. This will cross cancel. Now, in this case, when you're multiplying exponents, or you're using scientific notation, on my calculator I press EXP. Some of you would use E. Some of you will have it times 10 to the as well. So you kind of have to figure it out for your calculator. So the number of atoms would be, for me, 9.0 times 10 to the 23rd atoms of calcium. All right, what about 1.25 moles of H2 to molecules, right? Molecules is something we can count. So we're going to use this as, again, so we'll say 1.25 moles of H2 times, and then 6.02 times 10 to the 23rd molecules of H2 over 1 mole of H2. This cancels here. I'm just going to multiply the top. 1.25 times 6.02 to the 23rd power times 10 to the 23rd gives you 7.53 times 10 to the 23rd. 10 to the 23rd molecules of H2. Okay. All right, what about if we want to go backwards? Let's say we have the number of atoms or the number of particles. We want to go back to moles. You're going to use the same conversion factor. Use Avogadro's number equals 1 mole. So let's say I start with 3.02 times 10 to the 23rd atoms of nitrogen. Well, now I'm going to put the particles on the bottom. In this case, the particles are atoms. And then 1 mole of nitrogen. So in this case, I'll take 3.02 to the 23rd power times 10 to the 23rd and divide that by 6.02 to the 23rd. I get, let's see, I want to go to 3 sig figs. 1, 2, 3. So it's 0.502. And what are my units? Well, these cross cancel. So moles of nitrogen. The next one, I start with 3.65 times 10 to the 20th atoms of germanium. And I want to go to moles, so I'm going to multiply by this conversion factor up here, right? I know there's 6.02 times 10 to the 23rd atoms of germanium in 1 mole of germanium. All right, so I'll take 3.65 to the times 10 to the 20th and divide that by 6.02 to the 23rd. This equals 0.0006. I went 3 sig figs, 0.06. Atoms crossed out, so it moles of germanium. Now, you can convert this to scientific notation if you wanted to. Okay, we can do that as well. All right, so now we've learned converting between moles and particles, where we use Avogadro's number, or we can convert between moles and mass or grams, and that's when we use the molar mass. All right, so let's do some mixed practice. It says determine the number of moles in 8.0 grams of oxygen. So right now, I see a couple of things. Grams to moles. So we want to figure out the moles. So we're starting with grams. We want to get to moles. So I'm going to use the molar mass because I have a mass and I want to get to moles. So I know for oxygen, 1 mole of oxygen is O2 equals, and then O2, the molar mass of O2 is 16 times 2, which is 32 grams. I start with 8.0 grams, and then we put 32 grams of oxygen on the bottom because that allows me to cross cancel, and on top I'll have 1 mole of O2. I want to determine the number of moles, so I'm actually in good shape. I'll take 8.0, divide that by 32, and I'll get the moles. 8 divided by 32 is a quarter, right? So this is 0.25 moles of O2. It says how many formula units in 0.5 moles of calcium chloride. And we'll take a look at this. I want to figure out the number of formula units, right? Formula units, if you remember, are particles, just like atoms or molecules. So in this one, I'm going to use 1 mole of calcium chloride equals Avogadro's number because I want to figure out the number of particles. So I'm going to use 6.02 times 10 to the 23rd. In this case, it's going to be formula units. All right, so I start with 0.5 moles of calcium chloride times, and then 1 mole of calcium chloride, 6.02 times 10 to the 23rd. These are formula units of calcium chloride. So 1 mole, so 0.5 times 6.02 gives me 3.01. Now, I only have 1 sig fig here, so I'm just going to leave it at 3 times 10 to the 23rd formula units. We use, the abbreviation is FUs of calcium chloride. Okay. It says, what is the mass of 3.0 moles of sodium chloride? So you got to think, well, what am I going to use here? Am I going to use Avogadro's number, or am I going to use molar mass? Well, I want to figure out mass, so I'm going to use molar mass. Well, what is the molar mass of sodium chloride? 1 mole of sodium chloride. What's the mass? Well, Na is 22.99, right? And then chlorine, its mass is 35.45. Add those together, and the molar mass of sodium chloride is 58.44 grams. I'm starting with 3.0 moles of NaCl. So what's going to be on the bottom? Well, it's going to be mole of NaCl. Well, 1 mole of NaCl is 58.44 grams. So 3 times 58.44, these cross cancel, right? Gives me 175.32 grams of NaCl. Well, how many sig figs do I have? I have 2, so I'm going to choose this one. So it should be 180 grams of NaCl. Okay? My best piece of advice is to practice. So you have a homework and a key here. There's 10 problems for you to check out.